Introduction: a basic knowledge of soil stresses is necessary for geotechnical engineers to design and construct safe and durable constructions. So this study aims at investigating the various types of stresses present in soil masses and their impact on geotechnical structures. In civil engineering, accurate assessment and management of soil stress are essential to ensure the integrity and longevity of foundations, retaining walls, embankments, and other soil structural systems. The theoretical foundations of soil stress will be explored in this report, along with their generation and distribution within soil masses, in order to prevent structural failure and optimize design. It will also address practical applications demonstrating of how stress analysis is used in actual engineering projects.
I am Muhammad Denis Shekar, and I'm going to present the application of the importance of soil in civil engineering. First of all, it's important for foundation design because foundation stability depends on the soil properties and stresses. Engineers must design foundation based on the specific soil characteristic to ensure the structural stability and safety. It's also important for the hazard assessment because understanding soil stresses help identify potential hazards like liquefaction, sinkholes, and subsidence. Early hazard detection allow engineers to take preventive measures and protect people from potential dangers. Finally, the field vane shear test. This is used for measuring the undrained shear strength of cohesive soil. Useful for assessing shear strength of material like mortar and snow, which can cause landslides. Now we will take a look at the soil testing method that can be applied to understand the characteristic of soils. The first one is the cone penetration test. This test purpose is to determine the soil characteristic and geological condition, and it is applied to assess the soil density and behavior to evaluate soil resistance to collapse and predict soil response to earthquake. The second test is the Macintosh prop test. The purpose is to assess the soil bearing capacity, especially on soil surfaces. It is applied in the site investigation, foundation design, slope stability, and compaction control. And finally, we will have the sieve analysis test, which the purpose of this test is to determine the particle size distribution of granular material, and it is applied in road construction, filter design, foundation design, and earthwork.
Assalamu alaikum warahmatullahi wabarakatuh. My name is Abdul Nasser Abdullah Muhammad, and I will continue the presentation. Previous case study. So in this project, we will have four different case studies related to our topic. So in case number one, we have finding soil particle size through electrical resistivity in soil site investigations. So as we know, determining particle size is crucial in civil engineering due to its impact on soil strength and behavior. Also, traditional methods like sieve and hydrometer analysis are time-consuming, costly, and can stop the soil samples. So, in this case, the primary objective of this research is to develop a validated method for determining soil particle size distribution using electrical resistivity measurement. So the study aims to establish a correlation between soil resistivity and particle size, providing a simpler and more efficient alternative to conventional sheaf analysis. So let's move into the methodology. So during this research, we collect soil samples from 7 different sites at UCAM University and labeled A to G for analysis. Sheaf analysis was conducted according to ASTM P422 standards, and electrical resistivity measurements were taken using high-resistance digital multimeter at different moisture contents, which are 6%, 10%, and 14%. So as you can spot in this figure, we have the flow chart of how we did this research. First, we do the sample collection, and then take resistivity of each soil sample, and we dry the soil sample in temperature of 125 degrees Celsius. After that, we define the soil type using the shift test, and the first and the last stage we revealed the soil resistivity relationship for defining soil particle size distribution. So after we did the test, we come out with these two graphs, which represents the first one represents the particle size distribution of soil type A, B, and C, and the second one is soil resistivity measurement. So the particle size distribution curves of soil type A, B, and C shows the percentage of gravel, sand, silt, and clay in the soil samples. And we found out that soil type B contains 80% of sand, 14% of silt and clay, and 6% of gravel. And soil type A has 47% silt and clay, 21% of gravel, and 12% silt and clay. Soil type C consists of 67% of sand, 21% of gravel, and 12% of silt and clay. So in the soil resistivity measurements, also we took a different moisture contents of 6%, 10%, and 14%, showing correlation between soil resistivity and particle size. So in soil type A shows a resistivity of 0.41 mega ohm meter, and soil type B shows 0.67 mega ohm meter, and soil type C shows 0.89 mega ohm meter at 8% of moisture content.
Bismillahirrahmanirrahim. I will continue about my previous case study. About my previous case study is about the study was conducted in Sungai Langat, Malaysia, to investigate the correlation between soil erodibility and light penetrometer blow, Macintosh probe and B value. Soil samples were collected from various sites along the Sungai Langat River, and the Macintosh probe test was performed at each sampling location. The soil erodibility factor was calculated using two different equations. For the first one is Winchmeyer equation, and the second one is Tew equation, which are recommended for Malaysian soil condition. The study found a positive correlation between the soil erodibility factor and the content of very fine sand, silt, and clay in the soil. In contrast, it found a negative correlation between the erodibility factor and the sand and organic matter content. The relationship between erodibility and Macintosh probe value was influenced by the particle size distribution of the soil. The erodibility factor decreased as the particle size increased. The multiple regression analysis were performed to analyze the relationship between Macintosh probe value and K factor. The results show a weak and relatively non-significant effect between the two parameters. The study concluded that the Winchmeyer and Tew equation can be used to estimate soil erodibility based on Macintosh probe value, which can be a useful tool for predicting soil erosion in different regions. However, the particle size distribution of the soil need to be considered for accurate estimation. Thank you. This is my study area of the case study that I got three of soil layer. For the first one is surface soil layer. The depth is 0.0 until 0.5 meter, and then subsoil layer 0.5 until 1.0 meter, and then substratum layer from 1.0 until 1.5 meter. So this is my study area for the case study. Thank you. Okay, I will continue about the result. So based on this slide, this is on the right is one of the graph result. This one is percentage sand with k factor. So and the left one is different calculation between Winchmeer equation and Dew equation. So based on one of the result is first the comparison. The Winchmeer equation show a higher coefficient of determination value of 0.4109 compared to this two equation, which is the value is 0.2962. And then uh, the second one is descriptive statistic. The mean value of the K factor for the collected sample from Sungai Langat site were 0.0050 and 0.0045 for tube equation and Winchmeer equation respectively. And then for the last one point is skewness of kurtosis. The skewness value of the determined soil properties were found to be normally distributed, except for the fine sand content, which has had a positive skewness value of 2.529. The kurtosis value of the exam properties were in the acceptable range, except for very fine sand. Okay, thank you. Okay, touch pula. And then I will continue about the result of Prop Macintosh. So for the first one is Macintosh prop value. The Macintosh prop value range from 23 to 241, indicating varying level of soil resistance to penetration. Number two is correlation with soil properties. The Macintosh prop value were positively correlated with the fine salt, silt, and clay content, indicating that the particle contribute to the soil resistant to penetration. The value were negatively correlated with sand and organic matter content, suggesting that this particle reducing the soil resistant to penetration. And the last point is regression analysis. A multiple regression analysis was performed to analyze the relationship between Macintosh probe value and K factor calculated from both with Mere and Tew equation. The results show a weak and relatively not significant effect between Macintosh probe value and K factor, which p value is 0.05719, and for the Winchmeer and Tew equation is respectively. Thank you.
Now I'm going to give an overview of my case study, which is case study 3. This project is done nearby the Civil Engineering Lab at Ungku Omar Premier Polytechnic, and the purpose of the research is to discover the relative density of granular soil. Macintosh top is used during the test, and the importance of this test is to because it's essential for the construction design and ensure structure stability and prevent future accidents. The details of the Macintosh prop test is the reason we choose Macintosh over borehole is because the soil at the site is too soft for borehole sampling. And the example of site soil is gravel, sands, slits, clay with sands, and weak rocks. The output of the test is we will get soil sample with moisture content info. We will also get the soil type identification and classification. And finally, the soil samples can be tested for shear strain disturbance in the lab. Challenges of using the Macintosh prop test is underground gravel, cobbles, or boulders can disrupt the testing, and there could be a potential damage to equipment, and we could gain inaccurate data. The equipment that we will be using during this test is Rammer set, 1.2 meter steel rod, brush, ruler, coupling, bullet clamps, pipe wrench, chalks, and grease oils. The procedure is like this. Firstly, we assemble the equipment, mark the steel rod at 0.3 meter intervals, and then we mark the test area on the ground and count hammer blows to penetrate until 0.3 meter depth. And then we stop when the blow is at 400 blows or 50-meter depth. And then we record and tabulate data for analysis. What we will get from this observation is that we will get the number of hammer blow for 0.3 meter penetration. Now I will present to you the result and analysis that we get from this research. Research observations state that the depth that we reach is 4.5 meter and the initial penetration took about 30 blows for 0.3 meter. And then the difficulty of blowing increased as it took 44 blows for 0.6 meter and 49 blows for 0.9 meters. But then the difficulty decreased at 1.2 meter, which is 32 blows, and 2.7 meter, which take only 13 blows. The analysis that we can take from this test is soil stiffness decreases with depth and consistency inferred from the numbers of blows.
So for the case 4, uh, geotechnical properties of waste soil from closed construction dumping area in Serdang, Selangor, Malaysia. The waste soil is collected from a closed construction dumping area near Petronas Solari, Serdang, Selangor. The soil originated from the construction of a nearby buildings, which is nearly completed. The site was selected because it contains construction waste that meets the study's criteria. Three samples are collected from the different locations within the dumping area. Four tests are conducted on the samples to determine their properties. The first test performed a sieve analysis to determine grain size and classify the soil. The study aims to determine geotechnical properties of the waste soil. The research process is depicted in a flowchart starting from a literature review to property determination. So this figure shows the collected sample from three different locations. So we can see the location 1, location 2, and location 3. Uh, show the distinct properties in terms of color and content of the soil. So from this graph, we can see the result for the size of safe analysis of tree soil. So from this table 1 and table 2, we can see the result. So for the uniform coefficient, CU curve were calculated as 7.15, 0.04, and 4.27 for sample 1, sample 2, and sample 3, respectively. CU greater than 3 indicates a well-graded soil. Therefore, all three samples are considered well-graded based on CU, as their values are 7.15, 6.04, and 4.27, which are greater than 3. So for the coefficient of gradation, CC values are found to be 1.32, 0.87, and 1.09 for sample 1, sample 2, and sample 3 respectively. A well-graded soil typically has a CC between 0.5 and 2.0. thus based on three samples, are also considered well graded since their CC values are within the range of 0.5 to 2.0.
So we will move into the discussion for case 1. The study demonstrates that electrical resistivity is a viable method for determining soil particle size distribution. This technique offers several advantages over traditional sieve analysis, including reduced sample disturbance, faster testing times, and lower costs. The variation in resistivity based on particle size and moisture content provides a reliable metric for soil type identification in geotechnical investigations. The optimal moisture content range ensures consistent and accurate resistivity measurements.
Okay, Bismillahirrahmanirrahim. I will continue the discussion about my case study. For the first one is correlation between soil erodibility and light penetration penetrometer blow. The study investigated in correlation between soil erodibility and light penetrometer blow in Sungai Langat, Malaysia. The results show that the erodibility factor calculated using both Wishmere and Tew equation was positively correlated with very fine sand, silt and clay content. It was negatively correlated with sand and organic matter content. For the second one, particle size distribution, the relationship between erodibility and light penetrometer blow was influenced by the particle size distribution of soil. The erodibility factor decreased as the particle size increased, which is consistent with the idea that the larger particle is more difficult to detach and transport. So the last one is multiple regression analysis. A multiple regression analysis was performed to analyze the relationship between Macintosh probe MB value and K factor. The result show a weak and relatively non-significant effect between Macintosh probe MB value and K factor calculated from both Wishmere and Tew equation. Okay, that's all from me. Thank you.
Now I'm going to present the discussion of case 3. The study conducted by civil engineering students near the civil engineering lab at Ungku Omar Premier Polytechnic utilized the Macintosh probe test to assess the relative density of granular soil due to its simplicity and cost effectiveness. This method is favored for site investigation that helps ensure structure stability by considering soil properties and strength during design. Despite challenges such as underground obstacles that can skew result and damage equipments, the test provides valuable data on soil moisture contents, type, shear strengths, and information that is crucial for designing safe and stable structure, underscoring the importance of thorough soil testing in construction project.
Discussion case 4. The analysis of particle size is distribution of sample 1, 2, and 3. Reverse they are coarse grain soils, predominantly composed of gravel and sand. Sample 1 consists of 99.3% gravel and sand, clearly meeting coarse grain criteria. Sample 2 and 3 also show high percentage of gravel and sand, confirming their classification. Notably, sample 2 and 3 include gravel composed of natural and concrete mixture. These details are crucial for understanding soil mechanics and chemical properties, essential in engineering for foundation design, soil sustainability assessment, and environment impact evaluation. Detailed soil analysis ensure informed decision making in construction project. Additional, all three samples exhibit well-classified soil properties based on their uniformity coefficient (Cu) and coefficient of gradation (Cc). VCU values 7.15, 0.6.04, and 4.3 0.27 and CC values of 1.32, 0.87, and 1.09 respectively. This value indicate broad grain size distribution and confirm their well grade classification, contributing to their engineering classification and sustainability assessment.
Conclusion for case 1. This research establishes electrical resistivity as an effective alternative to conventional sheaf analysis for soil particle size determination. The method is simpler, cost-effective, and suitable for a wide range of applications in geotechnical engineering. For future research should focus on refining this technique and exploring its application in various soil types and conditions to further enhance its reliability and accuracy. Thank you, and that's all for me.
I will continue my my conclusion about my case study. So what I can conclude is, for the first one is correlation between soil erodibility and light penetrometer blow. The study conclude that the correlation between soil erodibility and light penetrometer blow is influenced by the particle size distribution of the soil. The results suggest such as which for the simple one is which is consistent with the idea that larger particles are more difficult to detach and transport. So for the second one is implementation for soil erodibility estimation. The study finding have implementation for the estimation of soil erodibility in different environment. The results suggest that the Winchmere and Tube equation can be used to estimate soil erodibility based on light penetrometer blow, which is can be useful tools for predicting soil erosion in different regions. Future research direction for the last one. The study highlight the importance of considering the particle size distribution of the soil when estimating erodibility. Future research can be focused on developing more accurate correlation between soil erodibility and lead penetrometer blow, as well as exploring other methods for estimating soil erodibility. So that's all from my case study. Thank you.
Now I'm going to present the conclusion for case 3. In conclusion, the lesson we learned from this research was the strength and bearing capacity of each layer of soils at the investigated sites. We also learned how the Macintosh test work and how to analyze and record the data gained from the test. Finally, we learned how each of the equipment of Macintosh tech work and how and what's the test different from the equipment of Macintosh test and JKR penetration test.
For the conclusion, case 4, the geotechnical properties of a landfill in Sedang Selangor were tested. Three soil samples were taken from the site and safe analysis, estimate compaction tests, and specific gravity tests were carried out. Safe analysis determined the droplet size distribution curve. The uniformity coefficient (Cu) of the soil sample varies from 4.27 to 7.15, while the grading coefficient (Cc) of the samples varies from 0.87 to 1.32.